So here I am logged into my Debian Linux machine, and we're going to insert the Grid Insight AMRUSB-1 utility meter data receiver, and I will show you how it will appear in the system so you can make sure that your computer recognizes it. Now this uses the USB communications device class driver, CDC driver, that is installed in Linux by default, in most Linuxes by default. So you shouldn't have to do anything other than just insert the receiver into an open USB port. So we'll show how this works here. Let's go into our devices directory and we'll list all of our existing TTY devices. This is where our serial devices appear. Okay, so let's take a look at that list. This includes a lot of devices, serial interfaces. Some are virtual TTYs, some are actual hardwired serial ports. S0, S1, S2, S3 would be the first 4 serial ports. I don't see any CDC USB type serial ports here, and that's good because I haven't inserted any yet. So now I'm going to insert the AMR USB-1 into a USB port. I had to reach under my desk there to do that, so it took me a minute. Okay, so that went in, and I can see the LED on the front of the receiver flashing. So it's getting power and it's initializing. So let's do another directory listing here and see if anything appeared. Oh, let's do a directory listing of just the TTY devices. Okay, so we see something new now. We see the TTY ACM0 appeared, and that's the default TTY name for a USB CDC class serial device. So the system recognized it without us doing anything other than inserting it into the USB port. So that's great. Let's go back to our home directory, clear this out, and we'll launch a tool that I installed, part of the Debian distribution called QtCom, which is a serial terminal. And I've already launched this one, so it already has plugged in the device name here, but I would normally have to type in /dev/TTY ACM0 here. And then I accepted all the other defaults. Baud rate doesn't matter, and all of these defaults here for serial configuration are fine. Take a look at these, and if you're using a different piece of software, make sure they match. So then I just hit Open Device. And I'm already receiving data. This was buffered, it looks like. So that's it. I'm going to stop now, and we'll come back in just a second, and I'll explain how this works and how we can interact with the device now that we're connected. Okay, here we are connected to the Grid Insight AMR USB-1 utility meter receiver, and you can see that in QtCom we are receiving data from the serial device here. This is standard NMEA 0183 sentence format. You can look that up and find all sorts of documentation on the format. Basically, each line is a separate data sentence coming in from the receiver over the serial line. And the structure is very straightforward. The first character is always a $, followed by a 5-letter sentence type identifier. Typically the first 2 letters of this identifies the type of serial device this is. In our case, it's a utility meter, UM. The next 3 characters indicates what type of message this is. And these messages are data messages from utility meters that are being picked up off of the air. This is a standard consumption message, SCM. And inside of an SCM message, there's a lot of data, but the key things here that we care about are this first field, which is the serial number of the utility meter transmitter. The next field is the ERT type. This is a code number that's assigned by Itron for a number of utility meter types. I can tell you the 13 is for certain water meter transmitters, water meter endpoints. In this case, this is coming from a Itron 60W ERT water transmitter. And the next field that's the 13. The 4 is a Schlumberger electricity meter, Centron electricity meter. The next field is the register read or the meter read for that meter. So this 7 value here shows me that this particular electricity meter has accumulated a total consumption since it was reset or installed of 7 kilowatt hours. This is not actually connected to a load, so it's been reading 7 kilowatt hours for quite a while now. The asterisk shows that that's the end of the data elements, and then the last 2 characters are a hexadecimal checksum. This is an ASCII value. You can recompute the checksum for any sentence by doing an exclusive OR on the ASCII values of all the data fields, including the commas. Very simple to recompute. And that's basically how this data works. Okay, so we're connected. Now I'd like to show some basic commands that the receiver understands and how it responds to them and what effect it has on the configuration of the device. So the first thing I'd like to show is changing the output from basic output, which we're seeing here, to full output. So I will type full on. You can see that we received a MSG message back, which basically just is a bit of text saying OK. It acknowledges that it received the command. Now notice that the format here has changed a little bit. The sentence type has changed from UMSCM to UMSCP, and these fields are still the same. This is the utility meter serial number, this is the ERT type, this is the register read, but we have 2 new fields, this one and this one. This is the frequency at which the signal, this particular data signal was received, and this is the signal strength. So the frequency is in 100 kilohertz units. So to understand this, really very straightforward. This is 914.8 megahertz. These are all within the 900 megahertz United States industrial, scientific, and medical band. You can see that we're receiving signals all over the place. Most of these are around 914 megahertz, and that's just a characteristic of this particular transmitter. We'll pick up data from other parts of the band depending on what type of meters we're listening to. But I do know that this particular type of meter likes to transmit in this range around 914, 915 megahertz. This last, as I said, is signal strength. This is a logarithmic scale. It ranges from about 90 or so on the low side, low signal, to about 230, maybe 240 for a really strong signal right next to the receiver. And this is not in decibels. It's essentially an arbitrary scale, but it is logarithmic in nature. And noise floor can range from about 90 to about 130 or so on this scale. So you'll see data coming in, depending on what the noise environment is like where you are running this receiver, at signal levels anywhere from 130 up. These transmissions are coming in from meters that are very nearby, and that's why these numbers are relatively high on the scale. So that's full mode. You'll get a little more information there about frequency and signal strength, which isn't essential for using the utility data, but is kind of interesting. So now let's take a look at some other basic commands. Right now we're in frequency hopping mode, auto tuning mode. I can turn that off by saying auto off. I can turn it back on by saying auto on. Very straightforward. And we also got an OK message to acknowledge that went through. Notice if I just type junk, we get an error message. Pretty standard. So now that we stopped auto tuning, the receiver will have just settled on whatever frequency it was listening to last in its hopping pattern. I can find out what frequency it happens to be on by using the RSSI command, received signal strength indication, which outputs a UMRSS message, received signal strength message. It says that we're currently camped out on 913.6 megahertz, and at that frequency the background noise level is at 126 on our signal strength scale. So that's fine. That's interesting. We can see that noise floor then for that channel is around 126, and these signals are coming in at 227, 174, way above the noise floor. They're nearby, so that makes sense. If I'd like to, I can change to a different frequency. Let's go someplace where I don't think there's any data. If I go to 903.0 to 9030, we should see that the data just stops. because I know there are no utility meters around here that are transmitting at that frequency, so we get no data. So that's fine. We can, while we're here, try a couple more commands while we don't have any meter data cluttering up the screen. scan does a spectrum scan, outputs a UMSCN message. This is pretty straightforward. We have one data field here that contains a bunch of numbers separated by colons. These are signal strength reads for 200 kilohertz separated channels, starting at 910 megahertz with the first one. At 123 is the signal strength there. Next one is at 910.2 megahertz. Next one is 910.4 megahertz, and so on. This is useful if you want to see what the noise levels look like across the spectrum. Now this is a subset of the entire ISM band. This goes from 910 to 920 megahertz, but it gives a range, a good feel for that section. It's useful for diagnostics, and that tends to be the part of the spectrum where most of the utility transmissions will be seen anyway. So we can see here that we have a couple channels where we have some reasonably higher signal levels. These are not problematic, but they're higher than the rest of the band. I think this is coming from interference generated by something here in the lab. I've tried the same receiver on other computers in other places, and there is no spur there. So my PC happens to be sending out interference. It's not really loud interference, but it's there. So you may see different numbers here, and you know, it's also possible that at the time we were scanning that particular frequency, there was actually data coming in from a receiver, or sorry, from a utility meter transmitter. So if you run this, you probably want to run it a couple times, and we just ran it again here, see if the pattern persists. It looks like we're still getting 140s on these two channels. So that's still pretty high, but generally this is a pretty good noise floor, and this is not bad at all. Signals coming in the 130 range are pretty far away, so we should be able to pick up anything above 130, 140 around here, and on some of these channels we're way down around 104, 110, which means that we're going to have pretty good receive range on this particular installation at this particular location. So I wouldn't say that noise is going to be a problem here at all. So we've covered received signal strength, we've covered the spectrum scan. Let's cover some other just basic commands. I can do a rset, which does a full reset on the system, and it'll take a minute for it to come back, but that will basically go back. There we go. Now it's receiving again. It flashed several times, went through its startup sequence, and now we're back to receiving data. So that's as if I had unplugged it and plugged it back in. Reset the firmware. I can see what version of firmware this is running by using the VRSN command. It spits out a UMVER message, which tells us this is a Grid Insight AMRUSB-1 running version 0.02 of the firmware, and there's a comment here that says this is beta firmware. So 3 columns, product, version, and comment. So this same structure could be applied to other devices and still be compatible. Let's also check out the serial number. Use the myID command, which outputs a serial number, UMSCR, and this is device number 8. So those are the basic commands one would use for interacting with the AMRUSB-1 utility meter receiver. There are some advanced commands having to do with adaptive tuning that we'll cover in another video.